Hello guys, and welcome to our first video lesson on transformations of parent functions. So hopefully you have found our Canvas page because you're watching this video right now. So step one, before you watch this video, go ahead and play a quiz is game reviewing parent functions from last class. After you've done that, I want you to open the Desmos graphing link, which will look like this. We're going to be using Desmos a lot this year. And then you should have these notes that the sub passed out. So what you're going to do is on the front page, you are going to do an investigation on what happens when you add numbers inside, outside, or in front of a function. And so I'm going to do the first one with you guys. So I have graphed the parent functions of quadratic, absolute value, linear, and another quadratic for you, and you guys are going to graph the transformation. So step one is you will go to Desmos and type in this new function. So I have x, and then you can do Shift 6 to do an exponent, or if you click this keyboard down here, you can also get squared that way. So I have got x squared, and then plus a 2. And so here is my transformed graph, and you would copy that roughly on your paper. So I can see this graph went up 2, so we are going to roughly graph this quadratic. And then right here, we are going to describe it. So I can see that the graph went up, and if you want to be more specific, it did in fact go up 2. Okay, and so we're done with that one. On this next one, we are going to graph this one in Desmos as well. So let me show you how to get the absolute value bars to come up. Again, if you are in this keyboard, the absolute value symbol is right here. And so that will give you the absolute value of x. And then I want to click on the outside over here and put plus 3. And so again, here is my transformed graph of my absolute value function. I can see that it physically went up 3. So on my paper, if you want to do 1, 2, 3, and draw a V and get more specific, that is totally up to you. Or if you just want to draw a V that was moved up. Then we're going to add some words. Hey, this graph was moved up 3. Let's go ahead and do this next one together. The next one is x minus 5. So I would go into Desmos and type in x minus 5. Now this one, I see that the graph is actually shifted down. So it's no longer going through the origin. It was moved down here. So again, if you want, you can do numbers 1, 2, 3, 4, 5. Hey, it's a line, but it is now shifted down 5. And so again, right here, I'd write in words, hey, this graph went down 5. Okay, so then you guys are going to try this next one on your own. But after you do this investigation, we are ultimately trying to come up with what is the pattern that we notice. And so I can already see a pattern right here. If the number was positive, hey, the graph went up. If the number was negative, hey, the graph went down. So if I'm making some assumptions right here, I'm going to assume, since that number was negative, that the graph is going to go down 4. But I'll let you guys figure that out if that's actually the case. So again, if you wanted to write a little blurb up here, if the number was positive, it went up. If the number was negative, it went down. Okay, so ultimately you guys are using Desmos to graph transformations and ultimately coming with up with a conclusion of when a graph is shifted. Okay, so you guys are going to try the rest of the page. There's some answer keys. I won't give them away yet. So try the whole page. You are more than welcome to work with your tables on Desmos, etc. So once you have done the entire front page, go ahead and press pause, and then you can come rejoin, and we'll go over the answers. So press pause. Good luck. All right, thanks for pressing pause and finishing this. So again, we've kind of already talked about the top. Here's what you should have gotten. So again, adding or subtracting outside of the function, and outside means at the end. If the number is positive, it's going to go up, and if it is negative, it is going to go down. So that's kind of the big takeaway from the first section. On the second section, adding or subtracting a number inside the function. So notice you have to have parentheses or bars to have it happen inside the function. So here's what your graphs should have looked like. Again, this graph is going to the right 2, this graph is going to the right 4, this graph went to the left 1, and this graph went to the left 3. Now, ultimately coming up with a conclusion, you would think a negative would shift it to the left. However, it went to the right. Same thing over here, you would think a positive would shift it to the right. However, it shifted it to the left. So this one's actually kind of tricky. So a negative inside the function is going to move it to the right. And a positive is going to move it to the left, which is the opposite of what your brain thinks. So what I do is if it's inside the function, it is the opposite of what you think. All right. Now, lastly, I hope you noticed that these were negative signs, not just dash marks. If you did not, that's my fault. Again, if you put a number in front of the function, it might be a little bit harder to see. So a 5x is actually going to be much steeper. So I did a terrible job of graphing this. It should still go through the origin, but is actually much steeper. On this next one, let me actually continue talking. So the word steeper, we talked about that last class. That was a good vocabulary word. We're actually going to introduce a new mathematical terminology. So instead of saying more steep, we are now going to call that a vertical stretch. So think about if you're stretching something up and down, it is going to get more taller. So instead of saying steeper, we are going to say vertical stretch. This function, it did get narrower, like it got smaller. And so again, instead of using the word steeper or narrower, we are going to call it this new vocabulary word, vertical stretch. So go ahead and make sure you write that down. Now this negative in front, we talked about flipping it over. And so instead of saying the word flip, we are now going to use the academic terminology reflected over the x-axis. Okay, so this function actually had two transformations happening. This negative in the front made it reflect, and then this 6 number actually made it get narrower, aka stretched it out. On this next one, this 1/4, it made it get much wider. Okay, so if you wrote wider, that's great. Now, a new academic vocabulary is called a vertical shrink or a vertical compress. So if it is getting shrank vertically, it's actually going to push it out, making it much wider. That one's pretty hard to remember. Again, the last thing, if you put a negative in front of the function, that is going to reflect it over the x-axis. So if you said flip, again, great. New vocabulary, reflect over the x-axis. This last one was kind of hard to see. It did get wider. So that's called a vertical compression. For being wider. Okay? So those are the transformations that can occur. And if you were able to figure out a common theme, if the number in front is bigger than 1, ignoring that negative, it is going to get more narrower, which we now call a vertical stretch. If the number in front was smaller than 1, typically a fraction, then it is going to get more wide, which we call a vertical compression or a vertical shrink. And then lastly, if you throw a negative in the front, it's going to flip it over the x-axis and reflect. So we're going to take all that information and put it into some nice notes. So on the back, in summary, we've got our function f of x, and something can happen outside of the function. It can happen inside the function. Oh gosh, writing is terrible on this thing. Or it can happen in front. So those are the 3 places you can add a transformation. So outside the function, behind it, inside the function, or in front of the function. So here are the 2 things. If your k value is positive, that is going to shift the graph up. If your k value is negative, that is going to shift the graph down. Okay? So the number behind it, outside of it, will tell you if your graph is shifting up or down. Next, inside the function. This one is tricky again. It's the backwards from what you would expect, and I would write that down. If it's positive, I think it goes to the right. It's actually going to the left, and that's what my brain has to do every single time. If it's a negative, I think that goes to the left. It's the opposite. It's actually going to the right. Okay? Now then lastly, you can put something in front. Now again, we look at the positive number for figuring out if it shrinks or stretch, but if your A is a negative, it's going to reflect. It's going to flip over the x-axis and be upside down. Okay, that's kind of the most easy one to pick out. Now then this symbol means greater than, so if it's more than 1, it is going to stretch, which means get skinnier or narrower. If your A value is smaller than 1, so like a half, a third, so on and so on, that's going to make it much wider, which is called a vertical compression. Okay, so again, these words were fine last class, but now we're going to start using these academic terminology to describe our functions. Okay, so that's kind of all the transformations that can occur. So press pause if you need to jot this down. All right, the next thing we're going to do is talk about sketching functions. And so obviously I could type this into Desmos and it would recreate a picture for me, okay? But this is a topic that would be in a non-calculator part of your test. So you would not have Desmos to sketch this graph. So it says for each function below, identify the family to which it belongs. So that's what we did last class. Then describe any transformations. And then the new part today is sketching a graph. So let's do a few together. All right, in part A, I've got f of x equals negative x plus 2. So I know if there's an x by itself, that makes it a linear function. So step 1, hey, that's its function family. Okay. The next thing is to describe any transformations. So I know last class, this was my parent function. So they've added 2 things to it. So I know I'm going to have 2 transformations to discuss. All right, this first thing, this negative, is it outside, in front, or inside? And so this negative is in front. And so I know if an A is negative, it's going to reflect over the x-axis. So I would say reflect over the x-axis. Okay. The next thing is this 2 is behind the function, so therefore it is outside the function, and it is positive, so I know it's going to shift up. So then I would say it's going to go up, and then it went up by 2. Okay, so that's kind of what we did last class. We talked about our transformations, but now the hard part today is graphing it without a calculator in your head. So step 1, it's a linear, so I know that's a diagonal line. I know the parent function usually looks like this, but now when I reflect it over the x-axis, it's going to flip. So instead of going up, my line's going to be going down. And then I need to move this graph up too. So usually your parent function goes through the origin, but now it's going to be shifted up too. So my graph's going to go up too, and then I'm going to sketch the best line that I can going down. And so that's our answer. Now if you wanted to, you could go to Desmos and type it in, negative x plus 2. Hey, I know I'm right. It matches my Desmos graph. Okay, but again, this would be a non-calculator skill that we're working on. Okay, so what I want you guys to do is press pause and try the rest on your own. Again, if you're stuck and all you can do is name the function family, that's great. If you can name the transformations, that's great. And then the hard part is obviously taking it to sketching a graph without a calculator. Okay, so go ahead, try those, and then in the next video we will go over the answers.